Unit 1. Teaching High School Chemistry. Unit Introduction. Chemistry as a discrete school subject usually begins at some stage of secondary schooling. Chemistry curriculum is prepared for each grade level by curriculum developers. Teachers are engaged in implementing the curriculum in actual classrooms. It is necessary that teachers understand the curriculum in order to implement effectively. Critical evaluation of the curriculum is one task of teachers before going into its implementation. Textbooks are one tool for student learning. Teachers should have a clear understanding of objectives, contents and activities in the textbook in order to use appropriate methodology for teaching different concepts. The selection of teaching methodology to teach a particular topic needs good knowledge of both content and methodology. Unit learning outcomes. On successful completion of this unit, you will be able to evaluate the relevance and organization of high school chemistry curriculum and textbooks, plan how to teach high school chemistry topics, use different teaching techniques such as problem solving, concept analysis, concept mapping, practical activities, demonstrations, group and individual assignments, presentation, discussion, etc. in peer teaching. 1.1. Evaluation of high school chemistry curriculum. A curriculum is a compilation of study materials that are used at all grade levels, classroom and homework, assignments and a set of teacher guides. It also includes a list of prescribed methodology and guidelines of teaching. Chemistry curriculum is developed for high schools for teaching at different levels. It consists of the subject matter including teacher and student roles that provide a setting for academic activities and learning opportunities. Teachers are primarily engaged in implementing the curriculum and have great role of delivering the curriculum in the classroom effectively. Teachers to deliver effective curriculum, they must be able to identify the qualities of the design, the contents, teaching methods or experiences, educational facilities and organization of the curriculum. For proper and effective implementation, teachers should evaluate the curriculum to understand the objectives, the contents and how well it can accomplish what it set out to achieve. Curriculum evaluation is the assessment of the merit and worth of a program of studies, a field of study or a course of study. Curriculum is evaluated for different purposes. As a teacher, to implement the curriculum, you are expected to evaluate its effectiveness in terms of its objectives, contents, student experience, organization and structure, teaching methods, teacher support materials and ease of application. Knowing about the quality of a curriculum is not only the concern of the teacher. It extends beyond and is the needs of policymakers, administrators and other members of the society. In-text question. Although evaluation has only one basic goal, which is determination of the worth or value, it has many roles. Curriculum is evaluated for different purposes. One of the functions of curriculum evaluation is determining the value of the curriculum itself. Saylor et al. 1981. Curriculum can be evaluated in terms of the content selection, sequence, and presentation, the effectiveness of the curriculum material, specification of instructional objectives on which the material is based, and the appropriateness of the materials are some other points for curriculum evaluation. 1.1.1 Methods of evaluating curriculum. How should you go about evaluating high school chemistry curriculum? There are different methods for evaluating curriculum. They describe how and what should be involved in evaluating a curriculum. In formal evaluation of a curriculum, one of the different proposed models can be used. As a secondary school chemistry teacher, the purpose of evaluating the curriculum is to make you understand the objectives of the curriculum related to the contents and their organization. This helps in the preparation of the appropriate plan for teaching. Evaluation judges characteristics such as selection of the contents, the sequence, presentation and the statements of the objectives in terms of behaviors that are desired to be acquired and their precision. The organization is evaluated based on the maturity, the interest and readiness of the learner, the difficulty of items to be learned, and relationship between items to be learned. The correlation and continuity of the curriculum with lower and higher grade chemistry curriculum is one part of the evaluation. In evaluating the content, you should focus on whether the topics are related to those learned at lower grade, are sequenced from the simple to complex, and are to the level of the students. The objectives of the curriculum should provide guidance for the curriculum implementers to adjust themselves accordingly to reach curriculum goals. The objectives of a curriculum can be evaluated using the Bloom's taxonomy of educational objectives using the 6 cognitive domains. These cognitive domains are arranged hierarchically in 6 categories, which are 1. Knowledge, 2. Comprehension, 3. Application, 4. Analysis, 5. Synthesis, 6. Evaluation. These cognitive domains can be used as a criterion for investigating the objectives in the curriculum guides. The objectives in the curriculum guides can be assessed in terms of the action verbs used and should be assigned to the best category in the taxonomy. This will help you to see the distribution of objectives in the 6 categories. An illustrative example is found in the case study done in Ethiopia presented below. Activity 1.1. Case study in Ethiopia. Analysis of chemistry curricula. Temakan 1991 analyzed the Ethiopian secondary school chemistry curricula of the previous regime and presented the results at the 8th Annual Congress of the Chemical Society of Ethiopia. The research used the Bloom's taxonomy of educational objectives cognitive domain to analyze the curriculum. The 6 categories of the Bloom's cognitive taxonomy were used to analyze the objectives found in grade 9-12 chemistry syllabuses. In the analysis, the action verbs of the objectives were assigned to one of the 6 categories. The secondary school chemistry syllabuses showed the following distribution of behavioral objectives. Item objectives: knowledge 53, comprehension 25, application 14, analysis 3, synthesis 5. Evaluation. A major finding of the present analysis is that the senior secondary school chemistry program did not attempt to develop all the categories of the cognitive behavior as perceived from the statements of objectives in the curriculum guide. Analysis of the statements of objectives further reveals that knowledge is the cognitive behavior most commonly demanded of the student by the objectives of the program, and the highest cognitive category is not reflected in the statement of objectives. The figures of the objective item in the table do not imply that the chemistry program as a whole did not reflect the higher categories. It can be argued that the way the statements of the objectives are formulated has made the distribution to be concentrated in the lower categories. This is evidenced by the fact that the curriculum under discussion attempted to develop all the categories to varying degrees. This is probably the most legitimate inference we could make from the investigation results about the worth of the program. It is, however, noticeable that knowledge and comprehension are the cognitive behaviors most commonly demanded of the student by the chemistry program. Activity 1.2 1.1.2 Evaluation of high school chemistry textbooks. Textbooks are important learning tools for students. Effectiveness of textbook in developing the concepts, abilities and attitudes in the learner should be examined. Favorable and successful textbooks are those which have good quality and methods of presentation, and would be able to help the learner in further learning. Textbooks are an important part of teaching, and must be used intelligently. It is necessary that the teacher evaluate the role of the textbook in his or her course, and re-evaluates periodically just to see how well the textbook is serving him or her, in order to bring out the good and bad points in any kind of qualitative and/or quantitative way that will help the teacher to choose the book that best suits his or her purpose. It is necessary to recognize that simple reading of it is not sufficient. Rather, some form of systematic and valid procedures should be used in order to become aware of the strengths and weaknesses of the textbooks. There are different techniques to evaluate students' textbooks to find their strengths and weaknesses. Some of these techniques are the use of Bloom's taxonomy, a qualitative analysis of the narratives, figures, questions, etc., analysis of conceptual development and analysis of the inquiry level of the text. You will evaluate grade 9 and 10 chemistry textbooks using Bloom's taxonomy and qualitative analysis techniques. In-text question 1.1.3 Evaluation of textbooks using the Bloom's taxonomy. The cognitive taxonomy can be used as a criterion for investigating the activities in the textbooks. Cognitive processes or behaviors required of students by practical activities in the chemistry textbooks should be identified. The key question to be asked as part of this identification process for each of the activities to be examined is, what is the student required to do in this activity? That is, what behavior is the student required to demonstrate? The answer to this question is in many cases suggested by the action verbs used in the activity. With the help of the answer to the key question and the action verbs used in the activities, an activity will be assigned to the best category in the taxonomy. In cases where the activity demands more than one behavior, the most complex behavior identified will be taken as the behavior required of the student by the activity, since the taxonomy is assumed to be hierarchical in nature. 1.1.4 Quantitative analysis of chemistry textbooks. The quantitative analysis involves all aspects of the textbook, such as the text, the figures, questions, etc. The technique for analyzing each of these aspects aspects as presented below. Rating the text. 1. Randomly select and mark 10 or more text pages from various parts of the book. 2. Read a block of 25 sentences on each of the marked pages, and assign each sentence to one of the categories listed below. If the page contains fewer than 25 sentences of normal text, continue on to the next page. Do not include headings, figure captions, summary questions, or chapter introduction in your sample. A statements of fact. Example: when HCl is placed on calcite, a reaction takes place in which carbon dioxide is formed. B. Stated conclusions or generalizations. Example: from its physical characteristics we conclude that NaCl is an ionic compound. C. Definitions. D. Questions asked, but answered immediately by the text. E. Questions requiring the student to analyze data. F. Statements requiring the student to formulate his or her own conclusions. G. Directions telling the student to perform and analyze some activity. Statements posing problems to be solved by the student. H. Questions that are asked to arouse student interest, but are not answered immediately by the text. 3. Calculate the index of student involvement for the text. E plus F plus G plus H slash A plus B plus C plus D. Rating the figures and diagrams in the text. 1. Randomly select 10 figures or diagrams in the book. 2. Analyze each figure or diagram and assign it to one or more of the following categories. A. Used strictly for illustrative purposes. B. Requires students to perform some activity or to use data. C. Illustrates how to set up the apparatus for an activity. D. Fits none of the categories. 3. Calculate the index of student involvement for the figures and diagrams. B/A rating of questions at the ends of text sections and chapters. 1. Randomly select 10 questions at the ends of 10 different chapters if available. 2. Assign each question to one of the following categories. A. Answer can be obtained directly from the text. B. Definition. C. Question requires student to apply learning from the chapter to new situations. D. Question requires student to solve a problem. 3. Calculate the index of student involvement for the questions. C plus E/A plus B. Rating the chapter summaries. 1. Select the chapter summaries from 3 different chapters. 2. Read 2 paragraphs of each of the 3 chapter summaries and assign each sentence to one of the following categories. A. Repeats the conclusions of the chapter. B. Raise new questions, the answers to which are not available in the text, or are subjects of current research in science. 3. Calculate the index of student involvement for the summaries. B/A. Determining the activities index for the textbook. Select at least 10 pages at random and glance through each, assigning an index as follows. Count the number of proposed activities required of the students. To get an index, divide the number of activities found by the number of pages examined. Guidelines for interpretation of data. Each index is calculated in such a way that 0 represents virtually no student involvement, 1.0 represents material with an equal number of statements requiring no student participation and statements requiring some student thought. Progressively higher index numbers represent progressively higher ratios of investigative material. Infinity would represent a textbook in which every statement and every figure would require analysis of some kind. An illustrative example is found in the case study done in Ethiopia presented below. In-text question. Activity 1.3. 1.2 Planning and teaching chemistry. Lesson planning and preparation are critical aspects of teaching and learning. Planning is the process of deciding what and how the students should learn. Teachers make such decision in the process of teaching. Lesson planning is always done before the lesson is taught, which means it is towards a preparation for the class, and not only in respect of the written material. When lesson plans have been well thought out and prepared in accordance, lessons will go much more smoothly, and it will be easier for students to achieve the goals of the lesson. Planning your teaching allows you to follow clear and precise goals, to effectively convey the materials you teach in an understandable manner. It makes you gain confidence in what you are teaching before going in front of students. Planning benefits both the teacher and the student, since both enjoy the process due to the well-thought-of strategy and method involved. It is important that as a teacher you are expected to spend sufficient time planning and preparing lesson plans prior to teaching the lesson. In this section you will learn how to prepare an effective lesson plan for teaching chemistry. In-text question 1.2.1. Preparation of lesson plan. Lesson plans are useful tools for planning a curriculum and allow you to follow clear and precise goals, to effectively convey the material you teach in an understandable manner. When planning a lesson, there are major components that should be included in the plan. What do you think are these major components? You will get answers to this question after completing this section. Planning requires gathering and recording information with respect to different inputs of the planning process. Some of the major inputs in a planning process are 1. What are objectives of the lesson that should be achieved among those included in the curriculum and test books? 2. To which learner needs should the instruction be directed? Learners' characteristics and individual differences. 3. What should be taught, and in what ways can the content be organized to produce the maximum amount of learning in the least amount of time? 4. How are the different teaching methods used to meet the objectives? Knowledge of teaching methods. 5. What instructional media and materials should be used to present the content and to test to see if it has been learned? How do you prepare a lesson plan making use of these inputs of a planning process? Lesson plan preparation starts from gathering of information about who are the learners. What do they already know? Why should they learn about this? What must they learn, and what must they do to learn? What students and teachers do at different stages of a lesson, and the smooth flow should be shown in the lesson plan prepared. The following are guidelines for preparing effective lesson plan. 1. Determine exactly what you want to teach, i.e. the lesson. This will be done based on the curriculum and grade level you are teaching. Once you have a determinate idea of what to teach, start developing how to teach the topic. 2. Set clear objectives. These objectives should not be activities. Each objective should convey what you want to know to teach, and what you want the student to know and understand. Objectives communicate to learners what is expected from them when they are shared with learners. Instructional objective must be specific, outcome-based, and measurable, and they must describe learner behavior. Lesson is constructs to reach one or more specific objectives. 3. Describe the learning activities. Lay out instructions step by step for each lesson. Develop a specific outline of each step in lesson. Include what you and your students will do during the lesson, teachers and learners' activities. Determine how to connect the previous lesson with the new lesson. This transitioning into a new lesson from a previous lesson will allow the new lesson to build on the older lesson. Include activities that help learners apply their learning to new situations on contents that allow to work in groups, in pairs or independently. 4. Include evaluation points in your lesson plan to access the student's comprehension of the lesson. Evaluation accesses each learner's attachment of the objective. Include oral, written or applied performance assessments. Your assessment items should align specifically to your lesson objective. 5. Use appropriate lesson plan format in which you can include the major components of your plan. The guidelines presented indicate major points to be included in your lesson plan. You can add other items depending on the nature of the topic you are teaching. You can be flexible in your plan. Activity 1.4, 1.2.2. Teaching some selected chemistry topics using different methods. You need knowledge of chemical contents for teaching. You must know what makes learning of specific topics easy and understandable. All chemical contents are not alike and can be categorized as facts, concepts, rules, and problems. Different teaching methodologies are necessary to teach different contents. You should be able to identify special chemistry topics and use appropriate strategies by selecting proper teaching methodologies. There are different techniques for teaching chemical concepts. You will be introduced to some of these techniques to teach some selected chemistry topics. In-text question. A. Teaching chemistry using problem-solving method. A problem is any question to be considered, solved, or answered. It is a question proposed for solution or discussion. It is anything that needs solution. Problems exist in many forms. They are very important in chemistry teaching. Students are required to solve different problems in chemistry. Problems in chemistry can be conceptualization in different ways. One way to classify them into two categories: generic problems and non-generic problems. Generic problems are standard problems that students are expected to master, while non-generic problems are those problems which are harder and cannot be solved easily by using simple algorithm. Problem may also be classified in different ways as routine versus non-routine, well-defined versus ill-defined, or adversarial versus non-adversarial. There are also other ways of classifying problems. What constitutes a problem and a solution in each of these domains varies greatly. Different problems are solved in different ways. How are we going to teach our students to solve different chemistry problems? There are different processes in problem solving. It involves many activities, and in some sense every problem-solving activity is unique. Still, procedures can be identified that are common to most problem-solving behavior. 4 general steps are identified: understanding the problem, representing the problem, executing a plan for solution, and verifying. Each of these are discussed in turn. A. Understanding the problem. Understanding the problem means understanding the task. One aspect is identification of the goal. For example, in the stoichiometric problems, the goal is to find the quantities of different species. The goal of the task should be identified correctly in the solution process. A second part of understanding a problem is understanding the conditions placed on the problem, and sometimes they are only implied. In stoichiometric problem, the atomic masses of elements and the laws of chemical combination pertain. These conditions are not stated in the problem, but presumably they are available to the problem solver. B. Representing the problem. Representing the problem pertains to how we understand the problem in reality. The way a problem is represented directly, and how often, whether it will be solved. It is representing to what the problem actually says. Familiarity with a particular type of problem helps to quickly represent the problem and facilitate the solution. Prior knowledge of solving similar problems is helpful in representing the problem. C. Executing a plan for solution. Once one has an internal representation of a problem, a way to reach the goal must be planned. Different decisions must be made during the problem-solving process. One of such decisions is to decide what operation to carry out. This is done based on your understanding and representation of the problem. At the completion of the operation, vacuo the knowledge obtained from the operation process. D. Verifying. Good problem solvers check their work. They use different strategies that verify procedures and conclusions are accurately executed. Many verification strategies depend on familiarity of content. This step depends on students to make good corrections of errors done from innocent inferences at some stages during operation. Verification is used to check the procedures followed or the solution reaches are valid. Activity 1.5 B. Teaching chemistry using concept analysis. In-text question. Chemical concepts are ideas about matter. Each concept is represented by a single word or phrase that has the same meaning as the whole chemical idea. Each of these words or phrases can be substituted for the idea it represents. Examples: acid, base, mole, mixture, titration, substance, element, hydrocarbon, triple bond, mass, chemical symbol, etc. You may ask yourself why each chemical concepts. From an educational point of view, concepts are important for a number of reasons. They help chemists and students make sense of the many things that they experience and represent some of the central defining ideas in chemistry. Because these ideas are so essential in understanding chemistry, It makes sense to occasionally teach lessons in which students are challenged to develop a deep and flexible understanding of important chemical concepts. So choosing one or more relevant chemical concepts will be the first step in planning your chemistry lessons. As you plan any chemical concept lesson, consider the following questions. What is the name most commonly associated with the concept? What is the concept's definition? What are the critical attributes of the concept? What non-critical attributes are associated with the concept? What are some interesting, learner-relevant examples or cases of the concept that can be used during the lesson? What are some contrasting non-examples that help clarify and illustrate the concept? What are the most interesting and efficient media that can be used to teach the concept? Concepts are difficult to learn and teach. This difficulty arises partly because both chemistry teachers and students do not engage themselves in thoroughly understanding the meanings of the chemical concepts. They are mostly engaged in understanding the concept in relation to other chemical contents. For instance, many complain that the concept of mole is difficult to teach and learn because students are unable to answer questions such as how many moles of water are in a liter of water. Surely this question involves the concept of mole, but it does not test for understanding of the concept. Being able to answer the question requires far more than concept learning. In concept learning and teaching, therefore, it is necessary to analyze the meanings of the concept thoroughly. The technique used in analyzing the meanings of a concept is simply called concept analysis. It is a tool used to uncover sources of difficulty in concept learning. Concept analysis involves different elements that are critical in teaching a lesson. The elements of a concept analysis are exemplified by taking the concept mole, adopt the concept name. A concept analysis begins by naming the concept under analysis. Example mole be a definition. The definition of the concept names the critical attributes and states the relationship among them. Example: a mole is the amount of substance of a system that contains as many elementary entities as there are carbon atoms in 0.012 kilograms of carbon-12. The elementary entity must be specified and may be an atom, a molecule, an ion, an electron, etc., or a specified group of such particles. C. Critical defining attributes. These are those features that must be present for an instance to be considered an example of the concept. Example: C1. Mole refers to an amount of substance. C2. A mole contains 6.02 x 10^23 elementary entities. C3. The elementary entity must be specified. Although an adequate definition of a concept always includes the all-critical attributes, in practice a definition identifies only some aspects of the essential characteristics critical or defining attributes. Essential characteristics are the criteria one uses to judge whether or not an item is an example of that concept. D. Variable attributes. These are those features that really do not matter. They may be present or absent in examples or non-examples. Example: V1. Kind of elementary entity considered. V2. Units used to describe amount. Each unit used must have an associated principle that relates amount in terms of that unit to amount in terms of number of elementary entities. E.g., there are 500 sheets in a ream of paper. Since there are an infinite number of variable attributes for any concept, mention only those that might cause confusion. What to include in a list of variable attributes depends on the purpose. For instance, while preparing a concept lesson for grade 8 students, you might include items that would be omitted in a lesson for grade 11 students. Supraordinate, coordinate, and subordinate concepts. An understanding of a concept often involves knowing the supraordinate, coordinate, and subordinate concepts to which it is related. Supraordinate concepts are at a higher level of generality than the concept under analysis. Example: measures of amount of substances. Supraordinate concept for mole. The target concept, e.g., mole, is always an example of a supraordinate concept, e.g., measures of amount of substance. Coordinate concepts are at the same level of generality as the target concept. Example: mass, number of particles, and volume are at the same level of generality as mole, because they all are examples of the supraordinate concept, measures of amount of substance. Therefore, mole, mass, number of particles, and volume are coordinate concepts. Subordinate concepts are at a lower level of generality than the target concept. Example: mole of atoms, mole of molecules, and mole of electrons are subordinate concepts for mole. Note that concept analyses could never include exhaustive lists of supraordinate, coordinate, and subordinate concepts. However, a few examples are commonly included to place the target concept within a larger context. Examples. Examples in a concept analysis should be as divergent as possible. They set the boundaries for the class under discussion. If all examples are similar, the boundaries are not clear. Usually, at least one example is given for every variable attribute that might cause confusion. In some cases, the collection of examples, rather than a specific example, demonstrates that an attribute varies across examples and non-examples. Non-examples. Attributes that are critical are clarified through non-examples. Non-examples lack one or more of the critical attributes of the concept. At least one non-example must be given for each critical attribute to provide the needed clarity. Non-examples are often matched with examples, so that the non-example is as near in likeness to the examples as possible, but is still lacking some attribute that is critical. The second example of concept analysis shows the use of the above steps in doing concept analysis. The common concept mixture can be analyzed as follows. Definition: macroscopic. A mixture is an aggregate of two or more substances, or phases of a single substance, each of which can be identified by one or more characteristic property. Microscopic. Is an aggregate of two or more kinds of particles, atoms, ions, or molecules that not bonded together by strong forces. Critical attributes. C1. Contains two or more substances or phases. C2. Each component can be identified on some basis. C3. The mixture lacks constant microscopic properties. C4. Contains two or more kinds of separate particles, microscopic. Variable attributes. V1. Components of the mixture. V2. Number of components. V3. Kind and number of phases. V4. Size of identifiable particles. V5. Ease of detecting variable properties. V6. Particles may be atoms, ions, radicals, or molecules. Microscopic subordinate concepts. Substance, matter. Coordinate concepts. Pure substance. Subordinate concepts. Homogeneous mixture, heterogeneous mixture. Activity 1.6. Teaching chemistry using concept mapping. Concepts are the basis for learning different chemical concepts. In previous sections you have seen what concepts are, and how concepts are analyzed to clarify their meaning and help students for better understanding in the process of teaching. Students learn different concepts. There are relationships among these concepts. New concepts are learned in connection to other concepts students already know. Such relationships constitute a large part of students' knowledge. The relationships among concepts are shown using concept maps. In-text question. A concept map is a concrete representation of abstract ideas. It is a diagrammatic or schematic representation of the meaningful relationships among concepts. The more links there are among the concepts, the greater the understanding now is shown. Concept mapping is a teaching and learning strategy which helps students to organize concepts into hierarchies. Students learn meaningfully by building knowledge on the basis of what they already know. In other words, new knowledge or new concepts acquire their meanings through relationships with existing knowledge, or concepts, and meaningful learning occurs when new knowledge is consciously related to relevant concepts which the student already possesses. Concept mapping enhances meaningful learning by leading students away from rote learning and toward true understanding of concepts and their relationships. Concept mapping is a useful tool for helping students learn about the structure of knowledge and the process of knowledge production or meta-knowledge. Concept mapping has been found not only useful in promoting students' understanding of science concepts, but also in facilitating students' abilities to solve problems and to answer questions that require application and synthesis of concepts. Furthermore, concept mapping is seen to promote a minds-on approach to learning. Students are able to construct knowledge in their own terms, and hence remember better what they have learned. As a diagnostic tool, concept mapping has allowed the teacher to establish the main ideas held by the students before they begin to experience new material. Such diagnosis has shown the teacher's spontaneous reasoning of students as well as their misconceptions or preconceptions which might have otherwise gone unnoticed. There is also evidence to show that concept maps can be used for formative as well as summative assessment. Concept maps represent the relationships between concepts in the form of sentences or propositions. A proposition is two or more concept labels joined by a linking word that describes how they relate to each other. This proposition clarifies the link between the concepts of graphite and black, and helps us understand a little more about each of them, that the color of graphite is black, and that the color black is the same color as the graphite. Concept maps are thus two-dimensional diagrams showing concept labels connected by lines with words written on each line to describe a relationship between the concepts. Research has shown that young children learn a few concepts early on in their development through direct experience and discovery, but most concept meanings are learned through the relationship of one concept to several other concepts in the form of propositions. Novak and Gunn, 1984. For example, consider the concept water and the following propositions about it. Water is colorless. Water is a universal solvent. Water consists of hydrogen bonding. Water is drunk by humans. The actual physical presence of water, which we experience through our senses, can help us develop meaning for the concept of water. The propositions above, however, help to clarify, make more precise, and enrich our understanding of what water is. Concept map is one of the means teachers can use to help their students to understand chemical topics. It is a teaching aid by which connections and relation of concepts are presented in an obvious way. In general, concept maps are systematic devices or diagrams of a set of concept meanings, and how they relate to each other can help both teachers and students select and recognize the key ideas they must focus on to achieve a specific learning task, can provide a kind of roadmap that shows how we link different concepts through propositions, can help with revision if one is drawn up after a learning task has been completed. It will provide a diagrammatic summary of what has been learned. Can help, if drawn up by oneself, us see clearly what we personally understand by concept, and the limitations of our understanding. Can help, after being drawn up by oneself, us recognize new relationships and meanings, or at least meanings we were not consciously aware of before making the map. Thus, concept mapping can be a creative activity and can help to stimulate creativity for teachers and learners. How to build a concept map. When you develop concept map, take into consideration the following main points. 1. Identify a focus question that addresses the problem, issues or knowledge domain you wish to map. Guided by this question, identify the concepts that are pertinent to the question and list these. You may find it helpful to list the concepts on post-it notes so they can be moved around. You may also use a computer program. Concept labels should be one word, and at most 2 or 3 words. 2. Rank orders the concepts by placing the broadest and most inclusive concepts. Sometimes this process leads to modification of the focus question, or writing a new focus question. 3. Work down the list and add more concepts as needed. 4. Begin to build your map by placing the most inclusive, most general concept S at the top. Usually there will only be 1, 2 or 3 more general concepts at the top of map. 5. Next, select the 3 or 4 sub-concepts to place under each general concept. Avoid placing more than 3 or 4 concepts under any other concept. If there seem to be more than that under a concept or sub-concept, it is usually possible to identify a suitable concept of intermediate inclusiveness, thus creating another level of hierarchy in your map. 6. Connect the concepts by lines. Label the lines with 1 or 2 linking words. The linking words should define the relationship between the 2 concepts, so that it reads as a valid statement or proposition. The connection creates meaning. When you hierarchically link together a large number of related ideas, you can see the structure of meaning for a given structure domain. 7. Rework the structure of your map, which may include adding, subtracting, or changing concepts. You may need to do this rework several times, and in fact this process can go on indefinitely as you gain new knowledge or new insights. This is where post-its are helpful, or better still, computer programs. 8. Look for cross-links between concepts in different sections of the map and label these lines. Cross-links can often help to see new creative relationships in the knowledge domain. 9. Specific examples of concepts can be attached to the concept labels, e.g. Golden Retriever is a specific example of a dog breed. 10. Concept maps could be made in many different forms for the same set of concepts. There is no one way to draw a concept map, as your understanding of relationships between concepts changes. So will your maps. Examples of chemical concept maps. Concept maps can be developed by students as a method of exploring their understanding, or by teachers to organize students' learning, or by students and teachers together. Concept mapping has the potential of helping students to construct conventional chemical ideas. You can teach concept mapping to students. How can we teach concept mapping to students? In teaching students how to draw concept maps, it is best to demonstrate how concept mapping is carried out with a topic which they have already mastered, or the content of which is familiar to them. The steps below relate to teaching students to draw a concept map on the familiar topic water and its changes of state. 1. Identity ideas related to the topic of water and its changes of states. Example: liquid, ice, solid, steam, water vapor, gas, condensation, freezing, boiling, evaporation, and so forth. 2. Write ideas on pieces of card or paper. 3. Arrange ideas which are related close together, e.g. ice, solid, water, liquid, steam, water vapor and gas. 4. Put most general ideas at the top, e.g. matter, followed by changes, followed by state and so forth. 5. Draw lines between related ideas. 6. Write words on lines drawn to describe relationships between ideas. From the contribution of students with prompting or cueing by the teacher, the relevant ideas elicited in the above procedure followed through, and the concept map below is developed. Concept map for the concept ideal gas. Some of the ideas related to ideal gases and their properties are: 1. Ideal gases have constant volume at STP. 2. Equal volume of ideal gases at the same temperature and pressure contain the same number of molecules. 3. The kinetic energy of ideal gases increase with temperature. 4. When a system at equilibrium is subjected to a stress, the system responds to reduce the stress. 5. The total pressure of a system of mixture of gases equals to the sum of the partial pressures of the component gases. Ideas which are closely related are arranged together, e.g., kinetic energy, temperature, pressure, partial pressure. Most general ideas are put at the top, e.g., volume, molecules, mixture. Lines are drawn between related ideas to show the relationship, e.g., volume, molecules, kinetic energy. Activity 1.7. 1.3. Assessment mechanism for evaluation of chemistry teaching. Classification assessment is an integral part of science instruction. An assessment is not a test. However, a test is one form of an assessment. An assessment incorporates a wide variety of tools for informing and improving instruction, for helping teachers and students improve their understanding of content, and for evaluating student performance and establishing grades. Teachers have a responsibility to not rely on only one or two major assessment tools in their chemistry course. Some students excel in writing, some in math, while others may be strong speakers or artists. Some students are pressured by written exams, some are not. The evaluation of students' learning must use a combination of different assessment tools along with the corresponding planning and follow-up activities. Teachers must first answer a very important question. Do you want to know how well your students are learning? Teachers who really want to know what their students know and understand will assess and reflect every day. Teachers should welcome evaluations of all types. Proper assessment will be used to continually adjust the classroom environment to improve learning. An assessment of a chemistry lesson can be measured using a quiz, lab practical exam, written exam, or student satisfaction survey form, or can be evaluated through observations or conversation. A formative assessment is accomplished during the learning process as knowledge is formed, which includes observing classroom and laboratory activities, posing questions during a lesson, taking a poll, or having an informal conversation. A summative assessment is performed at periodic intervals to assess a collection of knowledge at a particular point in time. A summative assessment includes quizzes, exams, lab reports, and term papers. Personal journals may be used to encourage periodic self-reflection to help students assess their progress. Local assessment tools are often very good for measuring locally identified student outcomes. Local tools are often designed by the teacher or a colleague, and can be formatted any way that is designed. They do not compare students beyond the local boundary, and can require much time and effort to develop. In-text question. Classroom assessment is broadly defined as any activity or experience that provides information about student learning. Teachers learn about student progress only through formal tests, examinations, and project, but also through moment-by-moment observation of student in action. They often conduct assessment through instructional activities. Much of students' learning is internal. To assess students' science knowledge, skills and strategies, and attitudes. You require a variety of tools and approaches. You ask questions, observe students engage in a variety of learning activities and processes, and examine student work in progress. You should engage students in peer assessment and self-assessment activities. The information that you and your students gain from assessment activities informs and shapes what happens in the classroom. Assessment always implies that some action will follow. To determine whether student learning outcomes have been achieved, student assessment must be an integrated part of teaching and learning. Assessment of student learning involves careful planning and systematic implementation. Assessment purposes, approaches, and tools should be developed with instructional approaches during the planning of the unit. In developing assessment tasks and methods, you determine what you are assessing, why you are assessing, how the assessment information will be used, who will receive the assessment information, and what assessment activities or tasks will allow students to demonstrate their learning in authentic ways. 1.3.1 Characteristics of effective assessment. In-text question. Effective assessment helps focus effort on implementing strategies to facilitate learning both inside and outside the classroom, and demonstrates the following characteristics: congruent with instruction and integral to it, ongoing and continuous, based on authentic tasks and meaningful science learning processes and contexts, based on criteria that students know and understand, appealing to their strengths, a collaborative process involving students, multidimensional, and uses a wide range of tools and methods, and focused on what students have learned and can do. Assessment requires teachers to be aware continually of the purpose of instruction. What do I want my students to learn? What can they do to show that they have learned it? How teachers assess depends on what they are assessing, whether they are assessing declarative knowledge, procedural knowledge, or attitudes and habits of mind. Declarative knowledge. If teachers wish to measure fact-based recall, declarative knowledge is the most straightforward dimension of learning to measure using traditional tools. The purpose of fostering scientific literacy, however, is not met if students simply memorize the declarative knowledge related to science. What is more important is whether students understand and are able to apply this knowledge. The challenge teachers face is to design tools that test the application of declarative knowledge. Procedural knowledge. Tools that are designed to test declarative knowledge cannot effectively assess skills and processes. For example, rather than trying to infer student processes by looking at final products, teachers assess procedural knowledge by observing students in action, by discussing their strategies with them and interviews, and by gathering data from student reflections. Attitudes and habits of mind. Attitudes and habits of mind cannot be assessed directly. They are implicit in what students do and say. Assessment tools typically describe the behaviors that reflect the attitudes and habits of scientifically literate individuals. They identify the attitudes and habits of mind that enhance science-related language learning and use, and provide students with the means to reflect on their own internal processes. For example, Rather than assigning global marks for class participation, teachers assess learning outcomes related to students' effective contributions to large and small groups. Assessment is intended to inform students of the programming emphasis and to help them focus on important aspects of learning. If teachers assess only the elements that are easiest to measure, students may focus only on those things. For example, if science courses place a high value on collaboration, creativity, and divergent thinking, learning outcomes that may be more difficult to measure, and then assessment tools and processes must reflect those values. The ways teachers assess what and how inform students of what is considered important in learning. Effective assessment is ongoing and continuous. Assessment that is woven into daily instruction offers students frequent opportunities to gain feedback, to modify their learning approaches and methods, and to observe their progress. You provide informal assessment by questioning students and offering comments. You should also conduct formal assessment at various stages of a project or unit of study. Continuous assessment provides ongoing opportunities for you to review and revise instruction, content, process emphasis, and learning resources. Effective assessment is based on authentic tasks and meaningful science. Assessment tasks in science should be authentic and meaningful tasks worth mastering for their own sake, rather than tasks designed simply to demonstrate student proficiency for teachers and others. Authentic assessment is embedded tasks that are similar to those performed by professionals as they do their jobs, usually associated with inquiry, hands-on and performance-based activities. Measure knowledge and ability both. Assess both content and higher-order thinking skills. Provide opportunities to demonstrate creativity, problem-solving and decision-making. Reflective of standards. Some examples of authentic assessments are: 1. Pre-instruction. Goal: assess students' prior knowledge, ideas, beliefs and attitudes in order to help them construct new knowledge. Strategies: teach arts, journal writing, drawings, interviews/conversations, surveys, concept maps too. During instruction. Goal: to gain insight into how or if students' knowledge, ideas, beliefs and attitudes are changing. Strategies: portfolios, journals, field books. Skills assessment: can the students use a balance, product assessment, video, audio, tests, quizzes, etc. 3. Post-instruction. Goal: to evaluate students' progress and reflect on the effectiveness and quality of instruction. Strategies: teacher evaluation forms, student interviews, written assignments, standardized tests, performance assessments, problem solving. Through assessment, teachers discover whether students can use knowledge, processes, and resources effectively to achieve worthwhile purposes. Authentic assessment asks not only tests of the information students possess, but also of the way their understanding of a subject has deepened, and of their ability to apply learning. They demonstrate to students the relevance and importance of learning. Performance-based tests are also a way of consolidating student learning. The perennial problem teachers have with teaching to the test is of less concern. If tests are authentic assessments of students' knowledge, skills and strategies, and attitudes. Activity 1.8. Effective assessment is based on criteria that students know and understand. Assessment criteria must be clearly established and made explicit to students before an assignment or test, so students can focus their efforts. Students should also understand clearly what successful accomplishment of each proposed task looks like. Models of student work from previous years and other examples assist students in developing personal learning goals. Each assessment task should test only those learning outcomes that have been identified to students. This means, for example, that laboratory skill tests need to be devised and marked to gather information about students' laboratory skills, not their ability to express ideas effectively when writing a laboratory report. Effective assessment is a collaborative process involving students. The ultimate purpose of assessment is to enable students to assess themselves. The gradual increase of student responsibility for assessment is aimed at developing students' dependence on teachers' comments for direction in learning and on marks for validation of their accomplishments. Assessment enhances students' metacognition. It helps them make judgments about their own learning and provides them with information for goal setting and self-monitoring. Teachers increase students' responsibility for assessment by requiring students to select the products and performances to demonstrate their learning, involving students in developing assessment criteria. Whenever possible, this clarifies the goals of a particular assignment and provides students with the vocabulary to discuss their work. Involving students in peer assessment, informally through peer conferences and formally using checklists. Having students use tools for reflection and self-assessment at every opportunity, e.g. self-assessment checklists, journals, identification and selection of goals, and self-assessment of portfolio items, and establishing a protocol for students who wish to challenge a teacher-assigned mark. Formal appeals are valuable exercises in persuasive writing and provide opportunities for students to examine their performance in light of the assessment criteria. Effective assessment focuses on what students have learned and can do, not on what they have not learned or cannot do. Assessment must be equitable. It must offer opportunities for success to every student. Effective assessment demonstrates the knowledge, skills and attitudes, and strategies of each student and the progress the student is making, rather than simply identifying deficits in learning. In-text question. To assess what students have learned and can do, teachers need a variety of strategies and approaches. Use a wide range of instruments to assess the multi-dimensional expressions of each student's learning, avoiding reliance upon rote memorization. Provide students with opportunities to learn from feedback and to refine their work, recognizing that not every assignment will be successful, nor will it become part of a summative evaluation. Examine several pieces of student work in assessing any particular learning outcome to ensure that data collected are valid basis for making generalizations about student learning. Develop complete student profit by using information from both learning outcome referenced assessment, which compares a student's performance to predetermined criteria, and self-referenced assessment, which compares a student's performance to her or his prior performance. Avoid using assessment for purposes of discipline or classroom control. Ryan, Connell, and S. in 1985 found that assessment, that is perceived as a tool for controlling student behavior, meting out rewards and punishments, rather than providing feedback on student learning, reduces student motivation. Students are sometimes assigned a mark of 0 for incomplete work. Averaging a 0 into the student's mark, however, means the mark no longer communicates accurate information about the student's achievement of science learning outcomes. Unfinished assignments signal personal or motivational problems that need to be addressed in appropriate and alternative ways. Allow students, when appropriate and possible, to choose how they will demonstrate their competence. Use assessment tools appropriate for assessing individual and unique products, processes, and performances. Unit summary. Curriculum evaluation, in present-day conception, refers to the process of studying the merit or worth of some aspect, or the whole of curriculum. Depending on the way in which the term curriculum is defined, the focus of curriculum evaluation could include curriculum and/or students' needs, instructional process, material used in instruction, objectives for students' outcomes, teacher effectiveness and outcomes of instructions. Teachers use curriculum as a basic tool for classroom instruction and have great role of implementing the curriculum. Evaluation focused to the immediate need of the teacher makes the teaching/learning process effective. Evaluation of curriculum using Bloom's taxonomy of educational objectives using the 6 cognitive domains is one way teachers can have better understanding of the curriculum. Textbooks, which are one tool of teaching, can be evaluated in similar way to investigate their relationship with the curriculum. Planning is one critical aspect of teaching and learning. Teachers should make the proper planning before they teach a lesson. They have to set a clear objective, describe the learning activities, and include evaluation points in the lesson plan. Teachers and learners benefit from thoughtful lesson planning which establishes a roadmap of what has been taught and what needs to be taught, and allows focusing on the objective and communicating to learners what they will learn in each lesson. Chemical content knowledge is needed for teaching. Different teaching methodology is also very important to teach different contents. There are a number of methodologies to teach different chemical concepts. Problem-solving methods of teaching is one of these methods which is connected to chemistry teaching and learning. There are different types of problems to be solved. There is no one set of problem-solving steps that can be taken to solve all problems, but most problem-solving includes efforts to understand the problem, represent the problem, plan and carry out some kind of solution, and verify that the procedures followed or the solution reached are valid. The most common goal of chemistry teaching, which is commonly cited, is getting STUDE for NTS to solve problems. Common impediment to problem solving is a lack of conceptual understanding. Concept analysis method of teaching is used to solve problems in concept learning. Concept analysis involving elements that are critical in teaching a lesson, such as defining the concept, identification of the critical and variable attributes of a concept, and selection of examples and non-examples that clarify the critical and variable attributes. Concept mapping is another method of teaching concept. It uses concept maps, which shows the relationships among concepts connected by lines with words written on each line, to describe a relationship between the concepts in a two-dimensional diagrams. One important benefit of concept mapping, among others, to the learner, is that it helps the learner about the structure of knowledge and the process of knowledge production. The usefulness of concept mapping to the teacher is that it helps in promoting student understanding of concepts. It also helps in the assessment of student learning, in particular, the diagnostic and formative aspects which enable the teacher to use the maps as starting points in building links between the prior knowledge and new knowledge that she or he intends the students to learn, as well as in addressing misconceptions or preconceptions that students may have at the beginning of learning each topic. Unit delivery approaches, methods, strategies, class observation, interview, independent work, presentation, post-work, reflections, peer teaching, group discussion, concept mapping, problem solving, evaluation, questioning, learner's activity. Actively participate in presentations and class discussions. Work on activities, homework, individual and group assignments. Evaluate high school chemistry text. Prepare reports and discuss in a class. Prepare daily lesson plan. Peer teaching. Post-work. Instructors' activities. Introducing contents and teaching methods. Facilitate during class discussion. Assisting learners during their work on assignments. Commenting on students' work. Arrange students into group to evaluate textbooks and teacher's guide. Evaluate students' presentations. Evaluate peer teaching. Assessment strategies and techniques. Evaluation of text review papers. Presentations. Participation in peer group evaluation. Quality of post-work and demonstration. Evaluation of peer teaching.